You could drive across the US in a few days. You could fly around the Earth in less than 2. But reaching another planet? That's a whole different level of waiting. Some people think getting to another planet is like a longer flight. Just hop on a rocket, point it at Mars, and go. But that's not how space travel works. Planets move, orbits change, and space isn't a straight road. It's more like a dance floor that's always spinning. So let's talk real numbers. How long would it actually take to reach each planet in our solar system if you left Earth today? Mercury. Mercury sounds easy. It's the closest planet to the Sun, and sometimes it even gets closer to Earth than Mars. So you'd think getting there would be quick. But no, Mercury is like that friend who lives nearby but is impossible to visit. The problem isn't distance, it's speed. When you go toward the Sun, gravity pulls you in faster and faster. To actually stop at Mercury, your spacecraft needs to slow down a lot. And slowing down in space takes more fuel than speeding up. That's why NASA's Messenger mission took 6.5 years to reach it. It didn't just fly straight there. It had to loop around Earth, then Venus, then past Mercury itself several times, using each pass to lose speed bit by bit until it could finally enter orbit. If you skipped all that and flew straight in, you'd reach Mercury in a few months, but you'd blow past it at thousands of kilometers per second and never stop. That's like missing your freeway exit by an entire continent. So yeah, Mercury may be close, but it's one of the hardest planets to actually stay at. Venus. Now Venus, that's our closest neighbor, and it's a lot simpler to reach. When Earth and Venus line up just right, they're about 38 million kilometers apart. That's practically next door in cosmic terms. Back in 1962, NASA's Mariner 2 made the trip in only 3.5 months, the first successful mission to another planet. More modern probes usually take 4 to 5 months, depending on the launch date and orbit alignment. If we ever sent humans there, the travel time wouldn't be much different than Mars. The real problem is what happens after you arrive. Venus has a surface temperature hot enough to melt lead, and an atmosphere thick enough to crush a submarine. It's basically Earth's evil twin. Same size, same shape, but living there would be like standing inside a pressure cooker full of acid. Still, as far as travel time goes, Venus wins for convenience. It's quick to reach, easy to aim for, and great for testing spacecraft before going farther. Mars. Mars is the celebrity of the solar system. Everyone talks about going there, Elon Musk wants to colonize it, NASA keeps sending rovers. But distance-wise, it's no quick trip. Mars orbits farther from the Sun than Earth, and the two planets move at different speeds. So sometimes they're on the same side of the Sun, close, and sometimes on opposite sides, far apart. The best time to go, called a launch window, only happens every 26 months when their orbits line up. When the timing's right, a trip to Mars takes around 7 to 9 months. That's how long the Curiosity and Perseverance rovers took. They launched, coasted most of the way, and then braked hard at the end to hit their landing zone. If we used faster propulsion, like nuclear thermal rockets or ion drives, we might cut that to 3 or 4 months, but those systems aren't ready for human missions yet. So for now, think of it like a one-way road trip that takes nearly a year. Jupiter. Now we start talking really far. Jupiter isn't just another planet, it's a gas giant, 780 million kilometers from the Sun. The Juno spacecraft, which arrived in 2016, took 5 years to get there. NASA's Galileo mission before that took almost 6, and both used clever tricks to make it happen. Gravity assists. A gravity assist is when you fly close to another planet to steal a bit of its motion, like slingshotting around a pole to speed up. It saves tons of fuel, but adds time, because you're taking the scenic route through the solar system. If we went straight to Jupiter using our fastest rocket engines, we could maybe do it in a year or 2. But straight lines aren't efficient in space, so we take the slow, smart path. It's a long trip, but the payoff is huge, literally. Jupiter is massive enough to fit more than 1,000 Earths inside it, and studying it helps us understand how the solar system formed. Saturn. Saturn is even farther, 1.4 billion kilometers from the Sun. And because of that, it takes serious patience to reach. NASA's Cassini spacecraft launched in 1997 and didn't arrive until 2004. That's almost 7 years. And like Juno, it used multiple gravity assists to get enough momentum. One around Venus, two around Earth, to get enough momentum. You can't just blast straight to Saturn, because you'd either run out of fuel or miss it completely. Everything in space moves, so you're aiming for where the planet will be years from now, not where it is today. By the time Cassini arrived, kids who watched its launch were in middle school, and yet it became one of the most successful missions ever, sending back breathtaking photos of Saturn's rings for over a decade. If we built a faster ship, maybe we could do it in 3 or 4 years, but for now, Saturn's still a long, cold trip. Uranus. Now we reach the outer solar system, where things get lonely. Uranus sits 2.9 billion kilometers from the Sun. That's so far that sunlight there is 400 times weaker than on Earth. Only one spacecraft has ever been there, Voyager 2. It launched in 1977 and reached Uranus in 9.5 years. And that was just a flyby. It didn't stop or orbit. If we launched a new probe today, with better engines, we could maybe shave it down to 8 years. But the truth is, Uranus doesn't get a lot of attention. It's cold, it's dim, and it doesn't have the dramatic storms or rings like Jupiter and Saturn. Still, it's a fascinating planet. It spins on its side, has faint blue rings, and probably an icy ocean deep inside. The distance just makes studying it painfully slow. Neptune, last stop for the planets. Neptune is 4.5 billion kilometers away. That's 30 times farther from the Sun than Earth is. Voyager 2 also visited Neptune, and that took 12 years. It passed by in 1989 and then kept going out into interstellar space. If you sent a spacecraft at the same speed as New Horizons, the one that went to Pluto, you could reach Neptune in about 9 years. But you wouldn't stop, you just fly past for a few minutes after nearly a decade of travel. At that distance, a radio signal from Neptune takes over 4 hours to reach Earth. That means if you sent a message saying hi, it would take 8 hours for the full conversation to bounce back. That's a long wait for a reply. Pluto. I know, Pluto's not a planet anymore, but come on, it's been part of the club for most of history, so it still deserves a mention. NASA's New Horizons launched in 2006 and reached Pluto in 9.5 years, the fastest trip across the solar system so far. It flew by at 50,000 kilometers per hour and had just a few hours to snap photos before racing onward. If it had tried to slow down, the journey would have taken decades. So, it didn't stop. It just waved as it passed. That's how far our solar system stretches. Even with our fastest technology, it takes almost a decade to cross it. These times might sound long, but in cosmic terms, they're lightning fast. We're shooting metal boxes across billions of kilometers, landing them with precision, and sending back data from places sunlight barely reaches. The real limit isn't speed, it's energy. Every time you go faster, you need exponentially more fuel. And if you can't slow down at the end, you just zip past your target forever. That's why we rely on timing, gravity, and patience. Exploring space isn't instant gratification, it's a relay race across generations. Scientists launch missions knowing they might be retired or even gone before the spacecraft finishes. It's long-term curiosity at its purest. Space makes you rethink what far really means. We live on one small rock, and the next one over can take years to reach. That gap, those impossible distances, is what makes space so humbling. When you hear about a probe spending a decade just to take a few pictures, it's not a delay, it's proof of how committed we are to curiosity. We're patient enough to send a message into the dark and wait years for the echo. Because exploring space isn't about speed, it's about endurance. Every mission is a reminder that progress in space, like in life, is slow, but it's always moving forward.